Okay, friends, let's talk about arc length here. I have a lovely circle in front of me, and let's suppose that I am given this radius. Let's make this radius 10. And then let's give us this angle too. So let's say that the angle in here is 100 degrees. So here's what you want to think. For arc length, you're wondering what this portion is. Well, one thing we can find is the circumference. So the circumference is all the way around. And circumference is found by doing 2 pi r. So in this case, since the radius is 10, the circumference is 20, because 2 times 20 is 10. So that's the whole way around. Now, we want to know this arc. So that's part. So part of the whole compared to the whole. Now, we can also do that with the angle information. The whole number of degrees in the whole circle all the way around, we'll spin in a circle, that's 360 degrees. So on top is the part. So we have the part that we care about to the whole, the part that we want to know, this blue part, to the whole. Now we just solve this equation. So to solve this equation, let's multiply both sides by 20 pi. Times 20 pi times 20 pi. On this side, those 20 pi's cancel out. So let's ignore the pi for now. Let's do 20 times 100 and then divide by 360. So I got 5.5 repeating pi. That's going to be what my question mark is. And I made up numbers, so nothing's going to come out too crazy nice. Now, if you want to, you could approximate pi with 3.14, so I can multiply by 3.14. And I can call it 17.4, just kind of keeps going. And that's the length of my arc. So that's one example. Let's look at a few more. So another situation we could be given is, what if we have the same idea, where we have this situation, but we know this arc length. Let's suppose this arc length is 20. And let's suppose that this part is 30.24. And I want to know what this is. Well, let's see. Once again, the circumference is the whole way around. So the circumference, which I would normally find by 2 pi r, well, in this case, I don't know what the radius is. So, but the circumference, I can just add them up. So the circumference is 30.24 plus 20, which is 50.24. So I can still do part to whole on this side. So the part I care about is the 20. That's in green. And then what I need to figure out is, wait, I know this total down here, because 360 degrees, that's a fixed number. Total number of degrees in the circle. And I don't know this part. So this is the same idea as before. Let's multiply both sides by 360. So we'll cancel out there and we'll cancel out here. And so we'll do, on our calculator, we will do 20 times 360 divided by 50.24. And we got 143, I'll call it 0.3. So that's the number of degrees in that arc. So that's another scenario we could be given. Okay, so our last example here. Let's try to be a little creative. Let's pretend that the radius of this circle is 9. And for the purposes of these problems, I'm going to use 3.14 for pi, just to make my life easier. But let's also suppose that I know that this distance is, I'll call it 50. I don't know. And let's see if we can figure out what this arc length is. Sorry. What this arc measure is. What that central angle is, I should say. So how we've started is we've found the circumference. Now to find the circumference, that's 2 pi r, and in this case r is 9, so 2 pi r is 56.52. Again, we're using that 3.14 for pi. Now that means that this leftover little bit right here is 6.52 because the whole distance around otherwise is 50, so 6.52 will make 56.52. Well, that gives me part 6.52 to the whole, which is the 56.52, not 25, but 52, and that's going to equal the part to the whole. So it's the same idea as last time. Let's multiply both sides by 360. So I'm going to do 6.52 times 360, and I'm going to divide by 56.52. When I do that, I get 41, I'll call it 41.5 degrees. And that found that central angle.